All right, so this is 1.2 basics of functions and their graphs. I broke this up into two parts just because it's kind of a long section. So here we're going to knock out this part one. Okay, so a set of ordered pairs is called a relation. So you can have any set of ordered pairs, and you can even use letters and stuff like that to create a relationship. A relation can be represented in several different ways. Here's ordered pair, table, that's pretty popular. We like to graph it sometimes. Then there's mapping. And so mapping's kind of like a table, except, so 1 goes to 2 and -2 goes to 4 and so on. It's the same thing. All these are actually the same exact, represent the same thing, just in a different format. Mapping, we'll see that a little bit, but that's kind of more to kind of explain concepts and stuff like that. So these three are the main ones that we're going to work with: ordered pairs, table, and graph. And then we don't want to forget about equations. Equations can represent a set of ordered pairs also. So we'll look at that a little bit later. Okay, so just a little bit more detail about relations. And the x values of a relation are the members of the domain. Okay, so the domain is basically just the x values, and the y values in the relationship are going to be the range. So if you were asked what's the domain from up above, you would just look at all the x values, and you notice they put it in numerical order. It's not absolutely necessary to do that. Some instructors are a little picky about that. Here, it's not really going to be a big deal if you put it in a different order. And then same thing for the range. So they went ahead and listed the range, -3 to 4, and so on. So that's relations. Now, what if you want to be a function? So a function is just a special type of relationship. That's all. And so for a relation to be a function, there must only be one output. There must be only one y value for each input x value. Okay, so the simplest way to kind of think about this is that x cannot have more than one partner. Okay, and so once we see an example or two, you'll kind of understand what this statement means. If these conditions are met, what we say is y is a function of x. So y basically is a function of x, basically means y is depending on what x does. So it's waiting on what is x going to do, and then that will result in what my y value is. Okay, so this first part just says, determine whether each relation is a function, give the domain and range of each relation. So this first one is not a function, and so the reason why is because x has more than one partner, the x value of 3. So if you notice, he's got a partner of 4 and a partner of 5, and so that's not good. And then you have the same issue here on the second two ordered pairs. But it just has to occur once. Once it occurs once, it's no longer a function, because the idea is, the way a function works is you plug something in and you want to get something unique back, okay? And you're not getting, if you're getting more than one value back in return, it's not unique. So if I plug in a 3, is it 4 or is it 5? And so it's not a function. So this one is not a function. And now we'll go ahead and list the domain, and so we use these little brackets or braces for set notation. And so you really don't need to list 3 twice, even though it's there twice. Just list it once, and then same thing with the 4. You just need to list it once. Okay, so even though it's not a function, it still has a domain and range and stuff like that. Remember, functions are just a special class of relations. Okay, range, that should be pretty easy. So let's see, it's going to be 4, 5, 4, 5. Once again, only want to go ahead and put it once. You don't want to repeat it. And so on number 5, we'll look at this one. And so they try to, let's see, there we go. On number 5 here, let's see, so we got 3 and -2, and then 5 and -2. So you might be like, wait a second, is that okay? Actually, yeah, it's okay if y repeats. Okay, so if y shows up twice. So when I plug in 3, I get a -2. When I plug in 5, I get a -2. That's okay. Back here, it's whenever you plug in something and you're getting 2 different results. So the same result can show up twice. So that's okay for the y value. And so as you look through here, you don't see x repeating, basically. That's what you kind of look for. So 3, 5, 7, 4. And so that's not a problem. So this one is a function. So yes. Oops, my pen's kind of going crazy on me. All right, so yes, and then the domain is going to be 3, 5. Let's see, let me try to fix this. Okay, so I think I got the pen working now. So let's see, 3, 5, 7, 4. And so I could have put the 4 between the 3 and the 5, but it doesn't make that big of a difference. Okay, so then the range, let's see, so -2 repeats, but that's okay. We'll just put it once. And then let's see, 1 and 9. So then 1, 9. And there you go. That's all you have to worry about on that. So for a relation to be a function, x basically can't appear more than once. So here we're fine. Over here, we had some issues. It was having multiple partners. Okay. Now we're going to talk about the vertical line test, and so that's going to be able to help us determine if if a graph is a function or not. So to be a function, every x value can only be paired with one y value. So we've already talked about that. Therefore, if any vertical line intersects the graph at more than one point, then the graph is not a function. To run this test, drag a vertical line across the graph. Okay, so what we're going to do here, I'm going to grab a vertical line. And so what happens is, as I take this, you can see it's touching at more than one spot. And so I'm just going to kind of estimate what these points are. But what's happening is x is partnering up with, it's having two partners. So let's just call this, let's say the x value is like -3 and the y value is coming back as, whatever, we'll keep it simple, 1. And then over here, -3, I'm getting -1. So that's not a function because what's happening is when x is -3, I'm getting two results. And so basically that disqualifies it from being a function. So this one would be no, not a function. The next one looks like that one would work okay if you were to drag a line across it. So go ahead and put yes for that one. Same thing on this next one. That one looks okay. So we'll go ahead and put a yes there. And then this part D, once again, we have some issues because if I were to take that vertical line, if I were to take a vertical line and drag it across, line tool is not working, but anyways, hopefully you can kind of see right there that that would be a no right there. So no, that one's not a function. All right, so let's go ahead and move on. Okay, so now this part's a little bit harder. It's determining whether you've got a function by just looking at an equation. So I kind of give you a hint on here to kind of figure it out pretty quickly, and that's basically if y has an even power, then it will not be a function. So you just really have to look at the exponent of y. Also, just note inequalities are not functions. I don't have any of those here listed, but I've seen them in other books where they might pose that question like, hey, is this a function? And so inequalities are not functions either. But anyways, all you're going to have to really focus on is the exponent of y. So if you look right here, that's just a 1. You're fine. So this one's yes. And just, we're going to be graphing all these functions throughout the course. So I'll just kind of let you know what you're dealing with here. Here, this would be a line. If you were to graph it, it would be a line. It'd pass the vertical line test, and you're fine. This next one, so the x has an even power, but we're not really concerned about that. You're just concerned about y. And so y, once again, it's not an even power, so you're fine. So this one's a function, yes. And this is one that probably many of y'all have graphed before. It's parabola shaped. It's kind of U-shaped like that. Okay, 15. Now we're finally going to run into one where we kind of have an issue. And so that's a y squared. So if y has an even power, then it's not a function. So right there, no. Just so you know what this one looks like, it's a circle, just so you know. And so just to kind of show you that it's not a function, I'll make some ordered pairs and show you. So let's say x is 4. Okay. Well, 4 to the second power is 16, so that gets taken care of. So y would just have to be 0, right? Okay. Well, what if x was -4? Well, -4 to the second power would become +16 again, and that would mean that y would have to equal 0 again. And so what you're seeing right here is that y's got a, oops, you know what? I think I did that actually backwards. So let me flip that around real quick. It'll take 2 seconds. So Instead, what we'll do is we'll let y be the 4, and then x would have to be 0. And if y were negative 4, same deal, then x is 0. So I'm sorry, I had that backwards. But as you can see, when x is 0, I'm coming up with two different results. That would be a problem, not a function, right? Okay, 17. Let's see. 17 right here, I've got an even power, so no. Okay, and once again, I could play around with the numbers and make a table and show you. Just so you know what this one looks like, it looks like a parabola, but it's on its side. This will actually be one that we won't graph in here. If you go ahead and go into pre-cal, you'll graph these. 19, okay, it's not an even power, so you're fine. So yes, it's a function. And just so you know, this is a square root function, and so they kind of, it looks like half of a parabola on its side, and we will graph this in a later unit. And then our last one, we've got a power of 3, not even, so you're fine. So yes, it's a function. And anyways, if you were to play around with this and graph it, it would look something like this. Kind of be like the number 19, except that it also goes the other direction also. Anyways, don't really have to worry about the graphs right now, but just looking ahead. Okay, so that takes care of that. So the next part we're going to look at is function notation. And so that's going to be important. Oops, there we go. So function notation. Oops, sorry, it's jumping around on me. There we go. So function notation here. So I've got an example of an equation. So y equals 3x minus 8. So the function notation, all we're going to do is basically name the equation. And so in this case, we replace the y with f of x. Sometimes when you're dealing with multiple equations, you'll call one f of x, the next one would be g of x, and then the next one maybe h of x, and so on. And so it just kind of helps you keep track of your different equations if we kind of name them. And so really f of x is really just y. So it's not f times x. Okay, so that's not what it means. A lot of times students have that misconception that it's saying, you know, f times x. No, it's actually pronounced f of x. And so what that means is we're going to replace x with different values, and what that tells you is, you know, evaluate your function at this value. So in my example over here, I have f of 5. So that's pronounced f of 5. And so you replace the x value with 5 and you solve it. And so therefore, when x is 5, y is going to be 7, because that was our result right there. So we substituted 5 in for x, and the result came back as 7, and so the result is your y value there. Okay, so we're going to try some of these. And we're going to start out pretty basic, but we'll get to some that have a little bit more going on. But let's see, 27. So right here we've got f of x equals 4x plus 5. And so all we're going to do here, sorry, I'm going to scroll down a little bit, is replace the x part with 6. So if we're going to evaluate f of 6, okay, so let's see, this is going to be 4 times 6 plus 5. So 4 times 6 is 24, plus 5 is 29. There you go. Okay. The next one's got a little bit more going on here. So you're actually going to replace the x value over here with x plus 1. Kind of interesting. So let's see, block that off. So f of x plus 1. So when you do this, you have to be careful, because if you just write 4x plus 1, that's actually incorrect. You have to put parentheses around what you're substituting in here to make sure that 4 is going to get distributed to both parts of what is being substituted in. And you don't want to forget about the plus 5 on the back end. Okay, so you got to distribute here, and then we'll just kind of clean it up a little bit, and that should be it for this. So let's see, 4x plus 4, and then a plus 5, and we can clean this up right here. So we're going to end up with 4x plus 9, and that's our result. That's what we want. Okay, so on part C, just to talk about a little terminology real quick. So whenever you see negative x, that's equivalent to saying negative 1 times x. So just kind of be aware of that. So here we go, f of negative x. So you're going to have 4 times negative x and then plus 5. So remember, we've got that understood negative 1 in front. So what we're going to do is just basically multiply 4 and negative 1 together. So this simplifies to negative 4x, and then don't forget the plus 5. And there you go. Okay, so I think I just have one more slide of these, and like I said, they'll get a little bit more interesting. We'll get some exponents and stuff like that. So here we go. Okay, so we've got these 3 here. So this first one, we're going to go ahead and plug in negative 1. Now what you'll notice is x appears more than once, but anywhere you see x, you're going to replace it with negative 1. So see, I replaced this with negative 1, so these two are going to be replaced. So we're going to have negative 1 squared plus 2 times negative 1 and then plus 3. Alright, so negative 1 times negative 1 turns positive 1. We have a plus 2, but it's getting multiplied by negative 1, so we'll go ahead and change that to a minus 2. And then you have a plus 3 right here. And here we go. 1 minus 2 is negative 1. Negative 1 plus 3 is positive 2. So that's what our result ends up being right there. Okay, so part B, you're going to have to recall some stuff from some of your previous math courses. And so let's go ahead and look at this. There's a very common mistake that students make on this problem right here. So let's look at this. So we're going to have x plus 5 squared plus 2 times x plus 5, and then we get that plus 3 right there. Okay, so the most common mistake students make is they write it as x squared plus 5 squared, and so that's not what's taking place here. Okay, so just to kind of review this concept over here, if I were to ask you, what's 5 squared, you'd say, well, 25. Well, where did you get that? Well, 5 times 5. Well, it's the same idea here. So if you have x plus 5 squared, what you really need to do is look at it as x plus 5 times x plus 5. And so what you have to do here is FOIL it. So we'll go ahead and FOIL it over here, and then I'll put it in place of my original problem. So FOILing, you're supposed to multiply the first two together. So x times x gives us x squared. Then x times 5, that'll give us a 5x. And then 5 times x again. So 5 times x, so I get another 5x. And then 5 times 5, which is 25. And so what you'll notice is the values in the middle are like terms, so we'll go ahead and simplify that. So x squared plus 10x and then plus 25. So that's what's going to take the place of this right here. Okay, so let's go ahead and put it in there. So let's see, x squared plus 10x plus 25. And then just to kind of color code this a little bit, so I'm going to go ahead and distribute this 2 here. So it'll be plus 2x plus 10. And then we don't want to forget about that plus 3 on the very end. So then the last thing we have to do is just clean it up, combine our like terms, and we will be good to go. So x squared, I don't see any others, so we'll start with that. Then let's see, I've got a 10x and a 2x. I think that's it, so we'll go ahead and put that as 12. Oops, pen's jumping around on me again. Let's see, 12x. And then let's see, we've got a plus 25, plus 10, and a plus 3. So let's see, 35, 38. So plus 38. Okay. And there you go. That's part B for you. So let's see, this is A, B, and then I'm going to go ahead and try to fit in C right here at the bottom. C shouldn't take up too much room. So part C, we're seeing another one of those negative x's. So I'm going to plug in negative x here. So let's see, that's going to be interesting. So let's see, negative x squared plus 2 times negative x, and then a plus 3. All right, well, remember the negative x has an understood negative 1 in front, okay? So you're going to square both of those. So when you square the negative 1, it becomes positive 1, and then x squared is just x squared. So what happens is when you square this negative x, it actually turns to a positive x squared. And then here you're, let's see, you've got plus 2 times negative x. Remember that's got that negative 1 in front, so really 2 times negative 1, which is negative 2, or minus 2, and then don't forget the x with it. And then you still have the plus 3 right there. And that is our result right there. Okay, so we just have a couple more. Okay, so x cubed. Okay, this shouldn't be too bad. So let's see, if we plug in negative 1, you're going to have negative 1 to the third power, and that's just going to result in negative 1. That's it. And I'll go ahead and show that to you just to make sure you understand where that comes from. So what happens is negative times a negative turns back to a positive 1. But then you have to multiply by negative 1 again, and so 1 times negative 1, we end up with negative 1. So that's what happened there. Okay, next one shouldn't be too bad. Let's see, 2 to the third power, just telling us to put a 2 there. So 2 times 2 is 4, and then times 2 again is 8. So be careful, a lot of times students want to say 6, but 8, 2 times 2 times 2. Okay, and then on part F over here, so we're going to take negative 3a, and we're going to raise it to the third power. So you'll have to remember your properties of exponents, and we kind of solved this on a previous up above problem. What you got to have to do here is cube the negative 3 and cube the a. Okay, so we got to cube both parts of this. So it's different. If there was addition or subtraction, it would be a different problem that we'd be working with. But since it's multiplication between these two values, you just go ahead and apply the exponent to both of them. So let's see, negative 3 to the third power. So negative 3 times negative 3 is 9. 9 times negative 3 one more time gives us a negative 27. And then you've got that a to the third power there. All right. Let's see what we got left. Looks like we got one left, I think. I don't think I have. Yeah, that starts the next part. All right, so last one. And so we're dealing with another polynomial. This time we have a fourth power, x to the fourth power minus x squared plus 1. So we'll go ahead and start with part A right here. So h of 2. So you're going to get 2 to the fourth power minus 2 to the second power plus 1. Okay, so 2 to the fourth power, 2 times 2 times 2 times 2, we should end up with a 16 right there, then minus, so that negative's not part of the 2 right here, okay? So when you square this, it's just 2 squared, which is 4, so that minus just stays where it's at, and then we have that plus 1. Okay, so we'll go ahead and see 16 take away 4 is 12. 12 plus 1 is 13. All right, so that's part A. Part B, we're going to plug in negative 1. So let's see part B. So we're going to have h of negative 1. So you're going to get negative 1 to the fourth power minus negative 1 to the second power plus 1. So negative 1 to the fourth power, basically, well, let's go ahead and talk about this. So if you have a negative 1 raised to any even power, it's always going to end up back to positive 1, okay? And if you have negative 1 raised to any odd power, it's always going to end up back at negative 1. And so that's what happens. You just keep going back and forth, positive, negative, positive, negative. So it just depends on, is your exponent even or odd? So in this case, we have an even exponent, so this is going to turn into a 1. And then we have minus, that's part of it, okay? But this actually turns into a 1, okay? And then you have your plus 1 on the back. And so we'll go ahead and, let's see, 1 minus 1, let's see, that's 0. 0 plus 1, that's 1. There you go. Okay, let's look at part C, and then I'll have to figure out where to put part D at the bottom somewhere. All right. Sorry, this is jumping around on me. Okay, so let's see. C. So let's see. We're going to have h of negative x. And so this is kind of interesting. So let's see. We're going to have negative x to the fourth power minus negative x to the second power, and then plus 1. So like the previous part, so I've got these understood ones in front, right? And so when I raise it to the fourth power, it turns that 1 into a positive. So really I have an understood positive 1, but then I have that x to the fourth power right there. So there's an understood 1, you don't need to write it. Then minus, and then the same thing's going to happen here. You square the negative 1, actually turns positive, and then you just left with that x squared. Now you do have the minus, but that's from the original function. And then we have our plus 1. So what's interesting about this is it actually gave us back the exact function we started with. And that's something we'll talk about in a later unit. This is known as an even function. So what happens here is it doesn't matter if I plug in 3 or negative 3, I'll actually get the same result. So if you really wanted to, you could plug in negative 2. If you plug in negative 2, you would actually still get 13. And so anyways, that's what an even function is. You get the same results if you plug in the same number, just the opposite sign. Okay, last one, D. Let's look at D. So h of 3a. So we go ahead and plug that in. So we're going to have 3a to the fourth power minus 3a squared, and then we get that plus 1 right there. Oops, jumping around on me. Okay. So here we go. So you're going to have to apply that fourth power to the 3 and the a. So you're going to end up with 81a to the fourth power minus, and then you square both of these. So this can be 9a squared, and then don't forget about your plus 1. And that's what we're working with. That's it. Okay, so I hope this is helpful. So you just need to complete the 1.2 part 1 assignment, and I'll see you guys on Tuesday next week.